So my talk is called Reflections on Building an Audio Plugin with Web Technology. Just to give a quick overview of basically what we're going to be talking about. First of all, I'd like to motivate this work to some degree. So why would we want to build an audio plugin using web technology? And also, what does that really mean? There's some existing work here, and so I'd like to touch on that just a little bit. And then kind of really dive into our approach to building an audio plugin using web tech. In addition to some of the advantages of this approach, I'd like to discuss some of the limitations as well as kind of further opportunities to continue using this kind of technology. And then conclude and open the floor to any questions that people have. So first of all, what is the plugin that we built? Earlier this year, we released, my team at Output released a plugin called Arcade. Which it's rather, we released a new version of Arcade. Arcade's been out for 2 years. It's a cloud-connected sample playground that kind of basically fits in your DAW. So it's a DAW plugin that includes both a sample-based audio engine, so lots of different ways to play with and manipulate samples, as well as kind of a network backend that's constantly providing new content in the form of both samples themselves. So these are just audio files that are generally loop type content, as well as presets for different sets of loops that we call kits. So these are pulled daily from a cloud backend. We have about 3,000 and counting kits, always adding more every day, as well as 44,000 and counting samples that you can access. Within Arcade, there's a rich web-like interface for finding and exploring all of this content that we're sort of constantly adding to it. So it's more than just kind of like a simple list of presets. There's actually a few different ways to dive into the content. So like I said, let me actually just show a little demo of this. So if you go into Arcade, it looks more or less like this. And so basically this whole interface we've built using web technology. So we can dive into different kinds of content, scroll through, see things, and they kind of load dynamically. We can filter by different types of instruments that we might be interested in. So strings, for instance, not a whole lot there in this particular area, but cinematic, bass line, oops, nothing turned out. We can also dive into a few different ways of exploring this content and even search for things. So we could search for funky drums, for instance, and see everything that corresponds to that. So as you can see, there's a few different ways to explore this data, and it's really important for us building this product that people be able to kind of like find what they need quickly and be able to make the kind of music they're looking to make. So if we go back here, play this in the window. Cool. So this is what it looks like. I just showed you that. I want to give a quick shout out to the project team. There were a lot of people involved in this project, and so I want to make sure that they're all recognized. Jay Caston, David Koo, Brian Furiyama, Neil Halleman, Igor Lanko, Rachel O'Ralde, Greg Lehrman, Justin Ma, John Nye, Patrick Perry, Colin Shepman, Trevor Steer, myself, and Colin Sullivan. So huge props to the team that put all this together across a variety of different roles and disciplines. And again, we released this earlier this year, September 2020. This is technically version 1.4 of Arcade, and the project was really to rebuild like a major component of it using web technology. So why did we do this? Why would we build an audio plugin using web technology? One of the major reasons for this was we decided to go down this route was improvements to the development process. Many of you have built GUIs in a variety of different languages. We typically build our audio software at Output using C++ and Juce, which is amazing, but it has certain limitations that we wanted to basically address. So one of them is basically shorter development iteration speed, shorter development iteration cycles, and being able to iterate faster and develop products and user interfaces quicker. For something like C++, you're often in this sort of, you write the code, then you compile it, then you run it cycle. And so if you want to make like kind of small little tweaks to the user interface to kind of see what happens if you kind of push things over this way a little bit, Or if we want to match like the design spec, we need to kind of shift some pixels around a little bit. It can be pretty laborious using C++, just because the iteration time for making these small changes is pretty long. So we imagine that building this on a web stack would be ultimately allow us to iterate faster. As well, this allows us to prototype quicker. So you can sort of build lots of user interface ideas quicker using JavaScript, in our opinion. And this ultimately leads to better products, because if you can prototype an idea really quickly, you can easily decide, is this a good idea? Is this going in the right direction? Should we keep going down this path for a particular user interface or user experience? And you can say, maybe this isn't the best path, and it's fine to throw it away because you haven't spent too much time on it. You don't have a whole lot of tech debt that you have to clean up or anything like that. So we were hoping that by building on a web-based technology stack, we would be able to prototype quicker as well. As well, the development tools for web-based development are pretty good. The browser-based tools that you can use basically to kind of go in and tweak just little things within the browser without having to go and recompile everything or rebuild everything. It enables a much deeper level of things like debugging and being able to kind of see what's going wrong with code or being able to tweak and test things. So there were some pretty clear wins just on the development side for wanting to choose this technology. And lastly, there's a rich third-party ecosystem with web-based technology. So Node.js and NPM kind of really open up a lot of different types of libraries that you can integrate to be able to build quickly and not have to reinvent the same wheels over and over again with a lot of commonly used type APIs or systems. So again, quite a few wins just in terms of the development process. As well, this is going to sound kind of like a little buzzwordy. I apologize in advance, but the web is basically, it's a cloud-native tech stack. C++ can have some challenges, I think, integrating with different types of cloud backends that we wanted to use. And so this includes things like Apollo and GraphQL, which are technologies that are very well supported in JavaScript, a little bit harder to get up and running with C++. Again, another big advantage of this is we can issue updates to Arcade dynamically and over the wire, basically by shipping a new JavaScript build. So an update using this technology stack means that basically you're just downloading a new set of code and you're able to sort of run that dynamically. Similar to how kind of like Slack or even Discord, for instance, every time they update, they just kind of show a little spinning dialog when you open it, and the next thing you know, it's updated and ready to go. As well, we wanted to have kind of a richer set of different kinds of media content within the plugin. So things like streaming video for tutorials or showing people basically how to use Arcade. Lastly, why would we use technology in an audio plugin? Better collaboration between design and engineering. I really feel that good plugins or good software in general, the more collaboration you have between the people who are designing it and the people who are building it, the more that kind of like boundary between those two disciplines is broken down, the better software you're going to end up with. And so we felt that by moving in this direction towards web technology, we could improve in this area. So modern design tools, for instance, are often very much web first. Figma, for instance, exports CSS files and definitions in the form of CSS definitions. Many designers are fluent in web tools, like CSS, for instance, and can even go in and change things themselves. As well, design systems can be defined in CSS and basically applied at will whenever those things are changed. So there's a lot of wins across all these different areas. Ergo, our motivation to pursue this kind of technology. I wanted to also call out some things that are non-motivations, or at least were not things that we were interested in for this particular project. So outside the scope of this project is fully web native audio software. Basically referring to, at the end of the day, this is running in a DAW. This is running in Ableton or Logic or Pro Tools or et cetera. This isn't going to be running in a browser. This isn't going to be running in a browser on your phone or anything like that. That's not our aim, but again, there's a lot of great tools for doing that if that is your goal. But we won't be talking about it today. Also outside of the scope is doing things like audio rendering and other kind of low-level type processing. Again, this is still in the context of a C++ based plugin. So audio rendering, for instance, is all happening in C++ and Juice, which are great for that for us. I also wanted to highlight some existing work in this area. Obviously, there's a very rich community of people doing various kinds of web audio work. In fact, there's a web audio conference that is cross-sponsored with the Audio Developer Conference. A couple of my friends are involved in the organization of that. Highly recommend checking that out if this is an area of technology that interests you. Blueprints, I saw a presentation on this at ADC last year. Very exciting stuff. It's a little bit different than our approach. With Blueprint, my understanding is that you are writing React, but similar to React Native, it's ultimately rendering to a Juice component. So it's kind of, you're writing JavaScript, but the end result is C++. iPlug2 is another exciting area of development with regards to web technology and audio software. It kind of approaches this from a couple of different directions, but for one, you can build web user interfaces embedded into your audio plugin using iPlug2, as I understand it. And as well, you can take your audio plugin and export that to WebAssembly to run it on any browser anywhere, which is also pretty exciting. So that's a little bit of the existing work in this area. So what about our approach? Well, to start with, we have Arcade itself. And this pretty much we had already built. This is the Arcade engine. And this is a Juice-based plugin. The audio engine itself, it includes the audio engine itself as well as a number of different GUI functions. This is communicating to an Arcade backend, which is written in Rails. This is running on the cloud somewhere. And we're using a REST API to connect to this. So what is this API providing? It's providing things like authentication. So when you log in, you get kind of the experience customized to you. We also check to make sure that you paid for it. This is also regularly gathering new content that, again, I mentioned earlier, we're publishing new loops, new kits, new samples every day. And so using this API, Arcade is able to fetch all of that. Again, this is all just basic Juice stuff. Within that, we have a web browser component. And so this is the starting point for our web-based GUI. And I'm gonna put a little star next to web browser component because in fact, we made a few modifications to support kind of some of our specific needs. Then within that, we're running the Arcade browser. So this is the interface you saw earlier. This is built in React. So essentially the web browser component provides a JavaScript execution engine and a web rendering, the ability to render HTML and CSS. And that's all embedded within the Juice plugin. These communicate with each other over WebSockets. So the Juice side and the regular web browser component doesn't really give you a lot of ways to interact with the web-based code that's running within the web browser component. So we actually had to build our own communication layer between what was happening in Juice and what was happening in the browser. So initially we used WebSockets for that. We kind of took a different approach a little bit later on in the project, which we'll come to later. And then the web browser itself, or sorry, the Arcade browser is communicating via GraphQL with the Arcade backend. So this is kind of the general overarching system diagram. Let's dive a little bit deeper into the React app. So this is basically just the Create React App template. Comes with a lot of powerful tools out of the box. And in production, if you go and download Arcade right now, essentially what you're getting is the Arcade engine as a plugin, and then a static build of the Arcade browser, which is bundled with the plugin that's being loaded every time you run Arcade. In development, we can either use the static builds or we can dynamically load it from the network. So this is really useful because if you just kind of start your Create React app, it's actually opening up a server that Arcade can connect to and sort of dynamically get whatever the latest development version of the browser is. So this allows for really fast iteration. You can basically change a couple things in the React app. It reloads automatically in Arcade. The other thing you can do is you can connect Arcade to just a standalone web browser and develop that way if for whatever reason you'd rather do it that way. Let's talk about this enhanced web browser component that we built. We made a few changes to this to really work with what our goals were. For one, we updated these to the latest OS rendering engines. So in Juce 5, it's using a couple of the older operating system specific rendering engines. So we updated these to be on Mac, WK WebView, which is kind of the latest and greatest on Mac platforms. And on Windows, we're also able to use WebView 2, which is kind of based on their new Edge browser. So these provided a huge speed boost for one, as well as some other enhancements in terms of how we can communicate with the web layer that I'll get into in a little bit. What this also enabled is basically allowing developer tools within the rendering engine itself. So if you're a developer of Arcade, you can go in and just right-click the interface and say, okay, let's inspect this element. Let's tweak things a little bit. Let's kind of shift things around and see what's going on wrong here, or like look at the console. Of course, this is for development builds only. In production, we don't want people going in and like kind of poking around too much and kind of what's going on under the hood. And you might ask, Juce 6 offers most of these things as well. Why don't we just use Juce 6? We started this project over a year ago. Juce 6 came out earlier this year, and it was essentially kind of pretty late in the development process to kind of make a large upgrade from Juce 5 to Juce 6. But it is exciting that Juce 6 has a lot of these technologies, kind of that a lot of developer time has been invested into making these technologies better in Juce 6, because I think it's just going to make this sort of thing much easier in the future for everyone else. Okay, diving deeper again, how do we communicate between Juce and web? Arcade specifically has pretty complex data sharing needs. We need to send lots of different types of data as well as different messages. So for instance, if I go into Arcade really quickly and say, if I click this and say download, this is actually sending a message to Juce to go and download whatever Poised is. And Poised includes both a set of loops as well as kind of like a preset file that defines like the state of the audio engine. And now if I go in here, I can play this. So here, now I'm kind of back into Juce land. So this whole interface is basically built in Juce. But if I switch back, this is another message to actually play the kit. So this tells the entire environment to switch over to this other mode. Another example is you can see an icon here that says this needs to be downloaded. And so the Juce side is actually sending a list of all the things that are downloaded to the browser. So this is all on web. That data basically needs to be communicated back and forth. So what I'm getting at is that there's basically some fairly sophisticated needs for sharing data between the Juce side of things and the web user interface. So that's why we basically went with WebSockets to start with, to share data between the two. WebSockets is kind of just a very low-level framework for sending messages between different kinds of, it's supported across a lot of different systems, but it has support in C++. We used a library in Boost called Beast, which actually has a bunch of different networking functionality baked into it. And WebSockets, of course, is supported natively by pretty much any modern browser, so it worked out of the box in our browser tech stack. Over WebSockets, we were sending a simple JSON-based protocol. So basically, the message itself was defined as a JSON data structure, which is very natural to use, of course, in both Juce and JavaScript. Both environments have great support for JSON. We looked into protocol buffers and kind of similar technology, but ultimately kind of proved to be a little bit cumbersome for our needs. So WebSockets was great for communicating between the two layers. We eventually decided to actually use something that we call direct communication between Juce and web, which more or less amounts to being able to directly call functions in C++ from JavaScript and being able to call JavaScript functions from C++. So this was a huge advantage of WK WebView as well as WebView 2, because they both enable you to do this pretty naturally, so that in the kind of Juice world, we can say, okay, do this thing, or show this screen or whatever. In the web world, we can say, okay, can you load this preset into the audio engine? And fundamentally, they can use the same JSON protocol. At the end of the day, we're just passing JSON around, and kind of the exact medium through which that JSON is passing can be changed between either this direct communication or WebSockets. So that was pretty natural to use, but it did require a little bit of development to orient towards WK WebView and WebView 2. So as far as the cloud communication part, using GraphQL was a huge win for us. It allowed, GraphQL has a bunch of advantages for us. The major ones were it really allowed us to construct this API a lot more flexibly, which is great. What does that really mean? Well, for one, we can update the API a lot easier. With a REST API, it's kind of like you're defining your endpoints, and then that has specific inputs and specific outputs. And if you needed to change that, thinking about things like backwards compatibility, like are there older clients who are going to still need to access this API and are expecting a different format? Those become problematic concerns, and over time, it kind of you're supporting a lot of different kinds of clients through a single API. GraphQL alleviates a lot of that burden for us, as well as very rich tools for building APIs, for interactively creating your schemas in GraphQL. And it also has the advantage where you only need to fetch needed data. With the REST API, you typically will get the same data no matter how much of that you throw away or how much of that you end up using. Whereas with GraphQL, you can say, just give me these fields, just give me this data. And you can also pull in the same request relational fields. So like kind of related data that might not normally be part of the specific data model you're looking for. So really useful, and you can fetch things quickly in a single request, and it's a huge improvement. By working in JavaScript and working with browser-based technologies, we were able to more seamlessly integrate with GraphQL and use that to connect to our backend. In theory, you could connect a C++-based app to GraphQL, but you would have to build a lot of framework. In our research, we couldn't find anything that allowed GraphQL to integrate seamlessly with C++. Cool, so did it work? In terms of development speed, generally yes. I think there were some hiccups though. For one, engineering around unknowns. So building the interface, there were certain limitations of using web browser component that we didn't really anticipate from the get-go. And so things that are very easy to do in Juice, we ended up having to do, it was much more work to get that working using web technologies. Tooling development as well was a big part of this. So building the tools basically to package all these things to make it so that it works really well in development, but also it can be deployed to production without needing experts in web technology to be, without needing your users to be experts in web technology or to be debugging things for you. So I think there's still a lot of room for improvement. In terms of kind of being able to interact with cloud-based backends natively, yes, 100%. This was a huge boost. In terms of the connection between design and engineering, I would say this part needs a little bit more tooling. We didn't really get there, but it's still potentially a big advantage of this approach. Cool. So some other considerations, really like if you're sharing basically data, if you're sharing areas of responsibility in your plugin between both web technology and kind of more traditional Juice or C++, you really have to think about your data model and where this data lives and how you're sharing data between the two. This was a huge sort of area of conversation for us. I wouldn't call it a problem necessarily, but it's something that you do have to think a lot about and how you're sharing this data. So I think there's probably some improvements in terms of like, how can you optimize the way data is shared between Juice and web, the web sides of this kind of architecture? Are you always going to be kind of forced to use message passing? Or is there a way where basically like entire data models can be represented on both sides and kind of like have updates to those be reflected across the two? Or is it more beneficial to think of Juice as kind of a server that the web client is then connecting to? And essentially you have kind of a multiple server client model where the web is a client of Juice and the web is also a client of kind of your backend server. A couple ways to go about it there. As well, I think the plugin editor dichotomy is always an interesting one here. And you know, this is one that always you have to consider if you're developing an audio plugin. The plugin itself, of course, you know, a rather, probably the better term to use there is processor. You always typically have an audio processor running if you're writing a software, an audio software plugin. So that's doing all the heavy lifting for your audio engine and doing the actual audio part. The editor is basically the graphical part. The editor typically can be deleted and removed at any time. So to that end, you kind of have to make sure that the critical functionality and your critical data models are remaining in the plugin itself. So this doesn't work so well if you have important data that's persistent in the JavaScript side of what you're doing. So ultimately, you sort of have to assume that anything in the JavaScript side is kind of volatile. But what would be an interesting direction to look into is like, is there a way to have a persistent execution model for the web-based code where JavaScript is able to sort of run continuously within the processor itself without necessarily being tied to the editor? Also, what does this mean for the user or customer? Like, ideally, this doesn't really mean anything because they're getting the same plugin no matter what. But what we hope is that by basing, you know, plugins on this technology, they're getting better products because we can build them faster, or we can have richer experiences for people. We can prototype and explore different ideas quicker and not have to worry about choosing one particular tech direction or another. So in conclusion, we essentially rebuilt Arcade using web technology, or at least we rebuilt 50% of it approximately. And this allowed us for faster development iteration. It allowed us to use cloud native technology frameworks such as GraphQL and Apollo. It improved collaboration between design and engineering, which were all huge wins for this project. The architecture itself is based on a React app running within a modified Juce web browser component. And we're able to communicate between the two layers using either WebSockets or kind of a direct kind of function call mechanism. So yeah, thank you very much. Happy to take any questions.
Awesome, thank you. Thank you, Spencer. Looks like we do have some questions that have come in on the Q&A panel. And if you have any questions, you can go ahead and throw them in there now, and we'll try to get to as many of these as we can. You could also upvote these questions here. So the first one is by Ruek. Are you sending any high frequency updates from the Juice engine to the web view? Modulation levels, output waveforms, etc. Is the engine/view communication fast enough to support this kind of approach?
Yeah, that's a really great question. And that was absolutely a concern that we had and continue to have. We are not sending any high frequency updates at this point. I think it probably would work for some things, but that was one of the reasons why we first started looking at protobuf, actually, was to be able to send these faster. The kind of direct communication method that I mentioned originally, we believe can better support this versus basically serializing a bunch of data to JSON, sending it over WebSocket, deserializing it. I think there will probably be some hangups there. So ultimately, there's some more research that needs to go into things like showing modulation levels or waveforms, things like that.
Awesome. Okay, the next one we have is from Oscar. He says, if I understand correctly, the plugin Synth UI is not written using web technologies, but is written using pure Juice. Is there a reason why you couldn't write the entire thing using web technologies, including the Synth UI?
There isn't a reason, no. Yeah, that's correct. Basically, the browser UI that I showed is based on web technologies, the kind of like more Synth UI. And in fact, I didn't show it really, but if you go into some of these kind of more, advanced editor panels, for things like changing pan or, different parts of the effects, this is all regular Juice. And probably the reason for that, first and foremost, is we already built this in Juice in the first place before the kind of web technology side of this had entered the discussion. So there was no real reason to rebuild it. But some of these things, we don't really see it now, but some of these things are also, you might want to redisplay modulation, for instance. And so you'll see this kind of like twisting and turning. Some of these more advanced user interfaces as well, I think would be a little bit harder with the model that we have, kind of relating as well to the previous question. So we could go down that path eventually, but for now, the big win for us was building kind of more of this interface in web.
Awesome. Ollie asked, there's a couple more. Ollie asked, did using WebView 2 on Windows result in lots of extra support? People without Edge installed. He's sorry he missed the beginning of the talk. Did you install the DLL?
Yeah, that's a good question. So the way we have it set up actually is if you don't have WebView 2, or rather, if you don't have Edge installed, there's one part of it that we are able to install automatically. But if you don't have Edge installed at all, we fall back to Internet Explorer, which also requires us to use WebSockets at this point. So we kind of have a couple of fallbacks there. So what we wanted ultimately was for this to be totally transparent to the user, to customers. So using a couple of kind of fallback mechanisms, we're able to generally make it work okay for people without having to get in touch with support.
Okay. Will says, did you find it easier to hire people to work on developing the UI?
It's a good question. I think, I would say the advantage of this approach, I would look at it a slightly different way. At Output, we have a lot of talented C++ developers, and as a result of this project, we have a lot of talent. We have a few talented front-end developers as well who work in web technologies. But where I think the real win is in terms of just who can work on this sort of thing is it opens up. It just makes it more accessible. And so if you learn programming through web technologies and you didn't learn Juice or something, or C++, you haven't gone into C++, but you went to a boot camp for how to build a React app, you can kind of dive in and start to mess around with this sort of thing. So I think that is a huge win for sure. And ultimately, that's how a lot of people are learning programming.
Awesome. Audrey says, you mentioned difficulties with the web UI components, things that are easier in Juice. Can you give some examples?
Yeah. Well, so some of the things that we really did need to do in Juice were things like, when in Arcade, if you, if I click download here, this is downloading some stuff. And the actual download itself is happening in Juice. And that's because just kind of that whole kind of low level data, chucking around data from the network to disk, et cetera, into an audio buffer. It's just much easier to mediate that on the C++ and Juice side. Some of the components here as well, these are built in Juice. I don't know if that would actually be that hard to build this stuff in web. I mean, it really wouldn't. But we did just happen to have it already built in Juice.
Chris,
some of these, some of these things, if we go into for instance, the waveform view, I think this would probably take a little bit of finesse to build this, kind of this waveform preview and editing view. And things like the kind of filter view. you certainly could build them in web, but they're a little bit easier to dial in Juice, I think.
All right, Chris says, is the backend node.js with socket.io, is Arcade built on top of Electron? And is there any way that he could try it? Sorry, I mispronounced your name.
Yeah, for sure. So the backend node, the backend itself, this is a little bit different than Electron in that we don't have, like, in Electron, you have two parts of your app. You have the front end, which is built in React, and you have kind of like a backend layer that is doing kind of other pieces, but it's all local to your actual like desktop computer. And the backend in that case is Node.js. So we don't actually use Node.js at all in any of this. In our case, the local backend is built in Juice. Then we have a web-based, like cloud backend running, on a cloud server somewhere. That's all built in Rails. So there's a few different kind of languages going on. Node.js actually isn't part of all of that, though. And then as to how can you try this, it's a great question. I'm working towards actually releasing some of the kind of core technologies behind this as open source. That's kind of a goal of mine. But ultimately, all of this is built on top of Juice. And so, we are standing on some pretty tall shoulders there. So ultimately, I think it wouldn't be that hard to build a lot of this without any of the tech that we have.
So related is what happens if the server's down or offline? Is there a way that you could develop the plugin to always work if it's offline?
Yeah, for sure. I won't try it now, but if I wanted to, I could turn my internet off, and this would all still work basically out of the box. You just wouldn't be able to get new content. So even though this is all running web code, it's running it from a local, it's basically running it as if it were a local server. So there's no reason you couldn't build a completely offline plugin using this kind of technology. You just have to make sure that the files, like the web files you want to load as your user interface, are available locally on disk.
Okay. All right, and let's see, we have another one that says, how do you / your team debug/test with web audio API?
It's a good question. So we actually don't use the web audio API specifically. So all the actual audio parts of this, those are still being accomplished in Juice. But in terms of just debugging and testing in general, we're able to use kind of the same sets of tools that you would use to debug and test any other web interface. This is our production version of the code, so I can't show you right now. But basically, what you can do is basically right-click, any of these elements in a development version and inspect the element, open up the console. There's actually even a way where you can get a link where if you open this in any other web browser, you can actually see the same interface. When you click the buttons, the same interactions happen as if you were running the interface natively within Arcade. So there's a pretty rich set of tools that we've enabled for front-end developers to debug and test with this technology.
Cool. And I think we got one more from Chris again. I think he's just clarifying. He's saying your JS code is interfacing with Juice, which assumes is C++, and interfacing locally, while Rails is on a server in the cloud.
Yep, 100% correct. Yeah, it's a local.
I think that someone asked this, he continues, but is the whole product to be implemented just using web audio API and React? So just JS.
I think you would run into some problems there with the web audio API running within a DAW. What we don't see here, I'm running basically a standalone version of Arcade, which is just kind of like it's just a regular app that you run. But typically the way people are going to use Arcade is within something like Ableton Live or Logic or FL Studio or et cetera. There's tons of DAWs that people use Arcade in. And so the interface between the DAW and the plugin itself the audio plugin is something that no web API that I'm aware of really handles in any way. So it would be interesting to see that direction, but I think ultimately it would take some work.
Cool. Let's see. Will says, do you test the UI in a web browser using standard web testing tools like Cypress, Selenium-based solutions?
That's a good question, and I think this does open up a much richer testing environment. I think that's one of the advantages I highlighted kind of really from the beginning of the talk, is that you can kind of tap into these tools that are really commonly used. We don't actually test that way. We do some degree of unit testing, but ultimately, yeah, there's no reason why you couldn't just test this the way you test any other web-based technology.
How do you record the plugin usage data for usage analytics, if any? That's a good question.
Yeah, that is a good question. I mean, ultimately that kind of question, there's really no reason why, we don't use Google Analytics or anything like that. We kind of like have a custom use analytics solution for this.
Okay, yeah, the questions are still coming in. So we still have like a couple minutes and we'll just go ahead and answer these. How much memory is consumed by one browser instance? Would you know? That
is a really good question. Off the top of my head, I couldn't tell you, but one of the explicit decisions that I didn't really touch on in the talk, but we explicitly decided to lean on the operating system specific JavaScript and rendering engines. So WK WebView is based on Safari, WebView 2 is based on Microsoft Edge. And in this way, they're at least Safari is like generally optimized pretty well to use memory and CPU usage in a way that's generally going to be favorable to the user experience that you're looking for. I think Electron is based on Chrome or Chromium, it certainly has a reputation of being heavy in terms of memory usage. How that compares against Safari, I don't have concrete numbers, but one of our goals in using Safari on Mac and using WebView 2 and Edge on Windows was to sort of preemptively confront some of these memory and CPU usage issues.